Okay, I apologize for the technical difficulties. We're back. I had to restart a couple of things, but we will actually get into the puzzle now. So, let's see what we have today. So, day 4, passport processing. You arrive at the airport, only realize you grabbed your North Pole credentials instead of your passport. While they're similar, North Pole credentials aren't actually issued by a country, and they aren't actually valid documentation for travel in most of the world. Okay. The automatic passport scanners are slow because they're having trouble detecting which passports have all required fields. The expected fields are, okay, birth year, issue year, expiration year, height, hair color, eye color, passport ID, country ID. Validated in batch files. Each passport is represented as key value pairs, separated by spaces or new lines. Passports are separated by blank lines. Okay. Third passport is interesting. Only missing field is CID, so it looks like data from North Pole credentials. Not passport at all. Two valid passports. Count the number of valid passports, those that have all required fields, but we treat CID as optional. Okay. So, let's go ahead and get our input. And let's go over here. We will start a new directory for day 4. Do part1.cc. You know the drill. Standard skeleton of a C++ program. And we'll make a build file to build it. Normally I would have done this ahead of time, but like I said earlier, we had a little bit of technical difficulties with the camera. I had to restart the stream. So we are not going to absolutely crush it on speed today, but like I was saying in the previous incarnation of this stream, that's okay. We don't always have to be the very fastest. So I am going to let's make a class that represents the fields inside a password. So we'll say class, or passport rather. And each of these fields that we're seeing in the puzzle here for these, each of these we can kind of treat, as one bit field, and all of these except perhaps country ID have to be set. So that's 1, 2, 3, 4, 5, 6, 7, 8 fields. So we can actually, let's just treat these as bit fields, and each one we'll say is a different one. So we can use really just a single byte as the rep. That fits quite nicely. So the uint8t, where it's an unsigned 8-bit integer, which is exactly big enough for what we want here. And let's make a little let's make a mapping of these strings that indicate the required fields to the bits that they correspond to in the representation. So we'll make this, static because it's shared. We'll use the abseil container library, use flat hash map. This is just a nice, really efficient hash-based container. So we're going to make a lookup table from those 3-character strings that indicate the fields of the passport to the bits that we're using that to represent them in our representation. So so this has static duration, so we're just allocating this once with new, initializing it once, and then we never delete it. But that's okay. It should live to the end of the scope of the program. It's just going to be shared by all implementations of passport fields, which is why we marked it static. So we'll do new of the same type here. Just copy and paste. And then we can do an initializer list here. So we'll say BYR, which is birth year, maps to 1. IYR issue year maps to, well, it maps to 2, but the way that we're going to do this is with we'll do this with left shifts. So that it's a little bit easier to read, just to do all those individual bits. EYR, expiration year, shift that 2 bits. That'll be 4, and so on and so forth. Height. Hair color. Shift that 4 bits. Eye color, shift 5 bits. Passport ID, shift 6 bits. And finally, country ID, shift 7 bits. So basically we've got, and what is this? Must be initialized out of line. Of course. I knew that. And put this initializer down here. This is C++ and there are rules, darn it. Yeah, I'll just do that. Format that nicely, thank you. Okay. So, to actually parse this, we will have some lines from the input. So basically, if we go back over and look at the puzzle description, we see that there are, I'm going to open up Twitch again too so that I can see anybody who's talking in the stream if in case I missed anything. But so yeah, they elements in here can be delimited by spaces or by new lines. So I think in our main function, we will go ahead and just use our old readlines.io routine, and then we will do little spans of that to get between new lines, and we will use that, and then we'll feed just spans of strings to this to process. So we will say we'll make a constructor that reads from the lines. So rep is initialized to 0, but basically for each string in the lines that make up a single password's description for each string in there, we will split that string using absol stir split. So we will just split it by the spaces, so we get the individual substrings. Just looking up the documentation for stir split right now. Yep, okay. So we are going to split the line, and we are going to do it by that single character. And for some reason that didn't autocomplete, but I'll go ahead and load that now. Okay. So for each of those fields, I'm not going to do the full input validation on this. We'll just go ahead and assume that the first 3 characters are a valid field name. So what we will do is we will or the so we're going to look up the substring of that field value pair, so the first 3 characters that indicates what the field is, in our map of fields to their bit representations in this representation bit field. So what we're doing here, we're using the substir method of absol string view to give us just the first 3 bytes there. The really cool thing about absol flat hash map, among other cool things, is that it supports heterogeneous lookup. So even though the keys in this are strings, we can look up with string views without having to do any type conversion, and it just happens automatically. We will check that we actually found the field that we were looking for, and that it's not, something that is totally malformed or just something that we don't know about. And then we will OR that bit in with all the other bits of the representation. So yeah, that gives us all of our passport fields. So now we just need a method that checks if something is valid. And that top bit CID is optional, but everything else is required. So what we actually need is just the number that we need to check that the representation is equal to the number with all of those lower 7 bits for all of the other fields set. So one easy way to do this is, we can take this one left shifted by 7, that's CID's value. We subtract 1 from that, and then we get something with all the bits that are lower order than that set. So we can return that number equals the representation. Okay, so that is all the passport fields logic that we're going to need, at least for this first part. I don't know about the second part yet. Now let's do the actual I/O. So we are going to check that we have exactly 2 arguments. So that's the program name itself and then the input file. We're going to read the input lines. From that file, check that that is okay. We'll keep account of the valid passports, and then so we're going to loop over these input lines, but we need to find subranges where we need to find the subranges that are delimited by blank lines that are just a new line. So we will, I guess, say so what we're going to do here is each time we come to a line that is just a new line by itself, we will make a new passport fields instance out of the lines between min and max, and then we will go ahead and do our valid check on that, and then we'll update min line and keep on iterating through the set like that. So we'll say if if the line is because read lines is going to trim off the new line, so just if the line is empty, then we will make a span. So I'm just going to look up the docs for absol span real quick. Yeah. I know that there's something simple that you can do for... Can you do it with just the iterators? You know what? We'll just use subspan. We'll just we'll just use like the span of the span of the whole thing, and we'll just take a subspan of it. So we'll do password fields. Oh, passport fields. Sorry. And we'll do absol make span. Hooray! From the lines, we'll say subspan. We'll go from min line to max line minus min line. We will increment our valid passports count if that's valid. Then we will reset the minimum line to the current maximum line. And we need to account for one past the end as well. So if then we will just make another one. And do basically the same thing here. Except instead of max line minus min line, we'll just leave that to the default parameter so that it goes all the way to the end. Okay, and then finally, we will print out number of valid passports that we detected. Okay, so we are going to need to go back, update our build file with all these glorious dependencies that we added. And I am going to use my standard copy and paste procedure for getting these deps in. At work, we have a really nice tool that automatically adds these for you, but I don't think that there's an open source version of it. So we need strings. We're also going to need flat hash map and span from Absol. Okie dokie. So let's take this thing out for a spin. And why don't we, I'm going to go ahead and just paste in actually, I'm going to delete the old one and just paste in the example from the puzzle to see if we get the answer right on that one. The great thing about advent of code is that, you know, all of these puzzles kind of come with at least one test case as just by way of explanation. And again, I spell that the wrong way. Let's see here. Okay. Okay. So our check failed here when we tried to find one of these things. So let's do the time-honored tradition of Printf debugging and see what the bad value is before we get there. Okay. It's empty. Oh, okay. So, yeah, there's a point where, yeah. we're feeding empty lines into this as well, I can tell. So I think we just I mean, break should be equally effective if we're actually parsing everything on the outside right, but we'll see. Okay. 1 is not the correct answer for that. It should have been 2 valid passports. So I'm going to need to do a little more debugging here, I guess. Let's print out the representation for each of these, just see if the bit fields are right. And we'll do that when isValid is called. So we should see for the test input, which remember is this, we should process 4 of these, and we can see what the bit fields look like. Can we put those in a binary format to make it extra nice to read? I don't know. Maybe. Can at least do it in hex, right? Get how to do this. I actually don't use I don't use the standard IO streams that much, but it's kind of the simplest thing to do in a simple program like this. So let me look it up. Oh yeah, I was doing that right. Okay. And just in case that is sticky, we will go back to decimal down here. Okay. Interesting. Oh, yeah. Okay, so these are represented as unsigned characters, which means that we need to cast them to an integer type, because otherwise the IO stream is just going to try and write them out as though they are characters. Yeah, because this here is just a typedef. Okay. So FF means all the bit in hex means all the bits are set. And so yeah, first passport is valid. That's fine. Second passport is invalid because it's missing the height field, and we have one of the lower order bits here is missing. That's fine. The third passport is only missing CID, only missing the top bit, so that should be fine. The fourth passport is... So the bit representations look right. So what else are we getting wrong here? Is it this part where we're checking the equality of these? Let's try printing that out. Okay, interesting. So it thinks that the third one, it correctly identifies the... Oh, of course. So we're doing equality here, but All right. Here's what happened. I was checking for equality with this mask, but really we just need to make sure that all these bits are set, and if anything else is set, that's gravy. Doesn't matter. So we'll say, namely the top order bit for country ID is set. It doesn't matter. That was just little oversight on my part, going a little fast, like fast and loose with the bit manipulations, but I can see what I did wrong now. So we'll make a little constant here for the valid bits. And then the way that we will actually check if this is valid is to check so we're gonna bitwise and our representation bit fields together with this mask. So we're going to mask out anything that's if anything is set in that top bit for country ID, doesn't matter, it'll go away. And then we're going to compare that with the mask itself to make sure that all those bits in the mask are set. This ought to work. Okay, it works correctly, at least for the input. Now let's give it a try for our actual puzzle input. Okay, so now we found another problem. Another problem with parsing, I guess. Let's go ahead and try and debug. Oh, I did it for day 3, not day 4. That's why I gave it the wrong input. Wrong dang input. There we go. All right. So our program says that there are 222 valid passports according to our hacked rules. Let's see if we're right. We got it. Congrats to us. Let's go on to part 2. The line is moving more quickly now, but you overhear security talking about how passwords and invalid data are getting through. Better add some data validation quick. We can continue to ignore the CID field, but each other field has strict rules about what values are valid for automatic validation. Okay, so we have to have fields that are both present and valid according to these rules. We have a list of some valid and some invalid passports. Okay. Continue to treat CID as optional. All right. So, yeah, for each of these, we just have to validate the rest of the string now. So, okay. So we basically have to do validation rules for each of these, and then we will only set something in our passport fields struct if it is truly valid. So I'm just going to make a copy of our part 1 and use that as the basis to start working on part 2. Okay. Yeah. So, okay, so looking at part 2, we can still use this stuff with all the bit fields, except that this part in here where we just, did like a lookup table to validate something is gonna get a little bit more complicated. So, let's add some helper methods in here that just implement the validation rules that they gave to us. So let's say we're going to use string view here for the value. We'll use this abcel simple 8i function, so we're going to try and parse the year into that integer. And if that doesn't work, well, if we can't parse it as an integer, obviously it's not valid. And then we will just return parsed year is greater than or equal to 1920 and less than or equal to 2002. Issued year is going to be something similar. Except here, it's between 2010 and 2020. Expiration year, we've got a lot of years here that, what the heck. Let's do, let's make this common. So what we're doing here is we're using this optional to represent whether something was successfully parsed or not. If it was not successfully parsed, we return null opt, which means no value. If it is successfully parsed, we return the value. And so we just can do, we parse the year, so we check that it has a value, it was successfully parsed, and then we can check that the value is in the range that we expect. Just want to follow the dry principle. Don't repeat yourself. Although I do a lot of copy and pasting on these puzzles, so, I felt like doing it this time anyway. So now this valid issue year becomes very similar. We just change the conditions to 2010, 2020. Expiration year. Again, very similar, but this time we want between 2020 and 2030. Okay, next one we're going to do is parsing height. Now, let's see. So we'll use if the value ends with centimeters, we're going to reuse this. We're going to make this even simpler. We're going to call this parse int. And then we'll parse the substring up to the last two characters. So Oh, yeah. We'll remove the suffix, I guess, here. Remove those last two characters for the centimeters. Make sure that it actually parsed, and then make sure that it's in range. This definitely seems heightist, that we're making sure that people have a certain height. But I don't know what to tell you. And we'll do something, a very similar pattern for inches. And if the value doesn't end in centimeters or inches, then it's not valid, and we'll just return false. So for inches, it has to be at least 59, and at most 76. Okay. So next thing we have to validate is hair color, which should be a pound sign followed by exactly 6 characters, 0 to 9, or A through F. Let me actually look up the ASCII table, because that is how I'm going to choose to implement this. Okay. Valid HCL for hair color. So this should be a pound sign followed by exactly 6 characters. So if the length is not exactly 7, obviously that is right out. If the first character is not the pound sign, again, right out. So for the rest of the characters, starting after that first position, if it's not in the range of 0 to 9 or A to F, or in other words, if it's not a hexadecimal digit, which conveniently Absol provides this ASCII is X digit function for. Return false, but we get through all those. They're all hexadecimal digits. We're all good. We should be valid. Okay. Eye color. This is just there's a set of valid strings that it could possibly be. So we just need to make sure that's one of those strings. So we can just use a flat hash set as a lookup table. To include this here. And the values in this, I'm just going to copy these straight out of the puzzle description, and we'll put some quotes around them. So they are amber, blue, brown, gray, green, hazel. Hazel was my great-grandmother's name. And the all-important other. Okay. Valid eye color. That's easy enough. We just check if the set contains the exact string. Okay, finally, passport ID is the last field that we need to check. It needs to be it needs to be a 9-digit number. It may have leading zeros. So, first, we'll just check the size. I'm manually writing this for loop here. The maybe more idiomatic C++ thing is to use some something from the algorithms library to check everything, but I'm not going to do that. Do I have to pass it a locale? Yeah, that's what I thought. Yeah, it can be in CC type. Yep, that's correct. Okay, so if C is not a digit, but if we get down here, it's true, everything's okay. And we don't need to write a validator for country ID because we are still going to be skipping that. So this fields thing, well, yeah, we'll keep that to just I guess indicate these stack things. I don't know if we're going to use that. So what we need to do now is for each of these field value pairs, we need to actually split it into the field and the value. So I would say, yeah, we'll say the field name is those first 3 characters. And the value is we skip 1 past the colon, which we're going to assume is always there, even though it might not always be there, but we'll hope that the input is at least that well formed. What the hell? We'll check that it's always there. And then we'll have our substring starting at position 4 and going all the way to the rest of the string, and that'll be the value. So we actually need to this is getting a little complicated, and there's going to be like a big series of if statements here to compare against all of these fields and dynamic and then kind of just do a dynamic dispatch to whichever one of the validation methods we actually need to use. So I'm going to go ahead and make a helper method to do this. Oh, and that actually should not be static, and it's because it's going to modify the state of the one instance of this particular class. So this will be kind of a helper for the constructor. So if field is BYR, we will check if that field is valid, if the value is valid, and then if so, we will OR in the bit for BYR in our representation. So I'm just going to use the literals here. I don't think it's really, there's not really reason to have that lookup table anymore because we are going to actually, be manually checking these fields all the time. So, the lookup table would just be additional cost. And so we're going to be following a very similar pattern for all the rest of the fields that we validate. So, for issue year, for expiration year, oh, and of course we have to make these shift left the appropriate amounts to fill in the right bit fields. For height, for hair color, for eye color, and got to keep remembering to go back and adding these shifts in so that we get the right bit positions. And finally, for passport ID. And then I guess, for country ID, it truly does not matter. But if we didn't parse, if nothing looked like a correct field, we'll go ahead and put a check fail down here just because we shouldn't get to that point. We'll hope that every field that we parse is actually valid. So now we go ahead and just call validate field with the field and value here in this loop up here. And I think this is everything we're going to need for part 2. Oh yeah, and we can get rid of the of this fields map. We're not using it anymore. Can get rid of that include for flat hash map too, because we're not using that anymore. Using optional, we're using span. So let's go ahead and set up the target for this in the build file. Going to need flat hash set now. We're going to need optional. Is that all the dependencies? Let me look at this again. Flash strings, optional span. Yep, should be good to go. So they gave us some examples of valid and invalid passports. So I'm going to make a little test file that has both. These are examples of invalid passports from the puzzle page. And these are examples of valid passports. So if we run this little we run our part 2 solution with this little test file, then it should count up to exactly 4 valid passports. And it counts up to 0. Okay, so we did something wrong. What could it have been? Let's do a little more printf debugging here. And see what the representations look like, and see what bits might be missing that we're not validating properly. Yeah. Okay. So all of the passports that should be valid should in fact be 7F, because they should have that second to highest bit set and not 3F. And so that indicates to me that the valid PID is not being set correctly. And that is because we did not paste it. You know what? That is just copy and paste error. We didn't actually edit all of those correctly when we went through, and I'm sure some of you may have watched this stream and seen my mistake earlier and pointed it out to me, and I am sorry that you did not see that. I did not see that sooner. But hey, our little debug string helped us out and showed us that. So now we run the program. It gives us 4, which ought to be the correct answer. So let's look at our actual input file again and see what answer it gives us. It says there's 140 valid passwords. So now the moment of truth for part 2, we see if 140 is correct. All right, we got it. So yeah, that's the solution for another day of Advent of Code. Got tripped up in a couple of places, obviously had some technical difficulties earlier, so I think that, yeah, we're, 6,000, 4,000, so we didn't get it quite as fast today, but you know what, that's okay. So, kind of thinking about the approach that we took today, using just individual bits, individual bit fields to represent whether certain things are valid or not is I mean, it's kind of a low-level approach, and if we were we would use an actual C++ class to represent a bit set if we wanted to do this in a scalable way, but I just immediately saw that there were only 8 fields, and so it was kind of simple to hard code it. But yeah, I mean, I'm decently happy with this solution. Might do a little bit of cleanup before I upload it to GitHub, but it will go up on my GitHub. That's github.com/Craig-Chasseur/AOC2020. I'll go ahead and put that up on the screen right now. You can see that path to my GitHub. This video will also go up on my YouTube channel, youtube.com/spoonboy42, where you can watch the replay. But thanks for once again coming and hanging out while we solve another day's worth of Advent of Code puzzles. This has been fun. Bye-bye, everyone.